If you're doing short runs, if you're doing 1 part, 25 parts, 100 parts, 50 parts, and you just have to have standard tools that just get it done every single day, that's where I actually use these go drills, right? Because they're my workhorses. Like we just stock them in the different sizes, and every time it comes up, we just make it happen. If I do big quotes, I basically quote them into my job, I buy them, and I just make it happen if I don't have the size, right? Just make it happen. Another thing that I'll say about the drills is these drills are 5 times D, okay? When I say 5 times D, that means 5 times diameter, okay? That means if this is a 1/2 inch, which it is, they're both 1/2 inch drills. If this is a 1/2 inch, then this guy can go 2.5 deep without actually pecking, okay? So it just boom, and it just goes 2.5, boom, 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 and all these little chips, little ones, just pop off, boom, 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 come out with the coolant and stuff, and they pop out of place, and it just goes 5 times D, all right? So how are we gonna test them? All I did was I actually went and got some material. I got some 1 by 2 by 6 inches, all right? So I got some material. This is basically the size right here. I popped in some holes in the material, and then I ordered the different types of material. So we have Delrin, we have aluminum, we have 4140, we have stainless steel 316, we have 604B titanium, and we're gonna show you Inconel. All right, you ready to go? Let's start off with the Delrin. It's a plastic that we use all the time. All right, it's the softest material that we're gonna cut today, but in being soft, it actually has its set of problems, right? It heats up quickly, right? Sometimes it's when you're pounding through and you're not using coolant through, you gotta peck it. You gotta peck it to keep cooling it so you don't actually retract that plastic too much, right? So if you drill in and you create a whole bunch of heat, it's gonna pull back on you, okay? So you gotta make sure your speeds and feeds are perfect and that you're cooling it down, all right? A couple other things is like if you're drilling something in plastic and you have too much pressure with the vise, you'll drill it and then you'll release it and it'll oblong, like it'll make your hole bigger, right? So plastic is an art. All right, so let's start off with black Delrin. We're gonna put our surface footage at 500, okay? And then our feed per rev, we're drilling, feed per rev is gonna be at 0.010, so 10 thousandths. Because it's plastic and because I'm gonna use a drill that is not coolant through, I'm actually gonna peck at a 0.5, so a 1/2 inch. I'm gonna drop down, boom, come out, coolant's gonna go in there, boom again, and I'm just gonna peck it down until we're all the way through the 2 inches. Now that we finished drilling it, like looking inside these holes, man, they're clean, they're perfect, right? One thing that I know about drilling plastic is that a lot of people, I've had some great machinists come into my shop and they're scared of it, right? They like, on average, they're like 25 inches a minute, right? Or 20 or 19 inches a minute, right? So there's jobs I've ran for years and years and years, and we like get through it. And then all of a sudden, somebody new gets on the machine, they're actually looking at the speeds and feeds, and they might have a problem, and they back off the feed, the feed per rev, they back off it, and guess what happens? The spindle keeps spinning, which creates heat, and you're not putting enough pressure on it, and it ends up heating up the material. Then they have bigger problems, and then they back off more, and then all of a sudden I'm like, dude, like, you got to push it. Like, let's go after it, right? Because that's the whole thing. Let's get into the material and get out of the material before it can heat up, right? Before it can do it. But you got to have the right drills. So these gold drills, they're amazing. Even in plastic, they break that chip, okay? So now let's go and actually do something that a lot of people don't do. Just take the coolant through, all right? 500 surface foot was good. But now let's go to the coolant through drill and let's double it. So in plastic, 1,000 surface foot. What, Titan? You're crazy. You're crazy. But I'm like, dude, let's do it. 1,000 surface foot. Now watch me now. Now the chip load, instead of being at 10, I'm actually going to go up to 14, okay? And that's going to give us a feed rate of 107 inches per minute, like 107, boom, in plastic. But guess what? We're cooling the plastic at the tip and allowing those chips to break. So watch it now, watch it now. 100 inches a minute. It had no issues whatsoever, and the holes look clean, man. When drilling all plastic, it usually retracts a little bit, right? So 1,000ths is kind of normal, okay? 1,000ths and a half, something like that is kind of normal. You just don't want to retract it where it's like 4,000ths under, 3,000ths under, okay? But like 1,000ths, 1,000 and a half, it's all good. All right, so now that the plastic is done, let's actually go to aluminum. So this guy doesn't actually have any coolant holes, okay? And it's just a carbide gold drill that gets after it. And if you actually look at the Academy, you look at the building blocks, what you see is this drill in it, okay? The Go drill. And we're giving it to all the kids in all the shops for education, like at below cost. Like, it's crazy, because we want you to learn on a tool that is a beast, so that when you go out into the real world, you can show companies how to compete with real tools, okay? Not mind the high speed stuff anymore. It's gotta be real. So aluminum, right? Especially like 6061 T6, you know, it's annealed, it breaks the chip nicely and stuff. So we're gonna actually take our surface foot from the plastic, we're gonna actually go up to 900 surface foot, okay? So we're gonna go to 900, and then our feed per rev is gonna be at 0.013, 13 thousandths, okay? And we're gonna get after it, but guess what? You know, the plastic, we did 1,000. This one, we're actually doing 900, but it doesn't have any coolant holes. All right, let's go. All right, look at that. It just killed it, right? 5 times D, no pecs. Boom! All the little chips come out. It's the same drill in aluminum and in plastic, making it happen. All right, making it happen. Now we're done with the aluminum. Let's go up to some 4140 steel. Let's get to some hard materials. So you can actually use either drill with coolant holes or without. For this, I'm actually going to use the coolant holes, right? We have the drills and we're going harder and harder and harder. So I just want to use the same exact drill to drill different materials. All right. So 4140 steel, let's get after it. All right. So surface footage. Oh, we're having fun now. So surface footage is going to be at 460. That's aggressive. It's getting after it, all right? 406 surface foot, and our feed per rev is going to be at 14 thousandths, all right? See how the adjustment happens, right? So now our surface footage is lower, but we're still pushing it, all right? So because it's steel, all right? So we're going to be at 14 thousandths, and that's going to give us a feed of at 50 inches a minute, all right? So let's get after it. impressive, right? So you see this guy just blasting through that steel, and it like was impressive. It was awesome. All right. Now check out these holes. Oh, they're clean, like they're beautiful, like they're nice. All right, so that's 4140. It's the same drill, the Go drill from Kennametal. We're still moving. Now, what about stainless? Now, stainless is a little bit different than regular steel. Regular steel, 4140, it's hard, but like you can actually get in there and make those chips fly out and stuff. Sometimes stainless, like it's abrasive, right? It's not like abrasive like copper, but it's abrasive and like it likes to like dull tools and stuff. So especially like 316. So let's try this same drill in 316 stainless, okay? You guys ready? My surface footage, right? My SFM is at 160. And then my feed per rev is at 0.007. And now you can see now from 460 in regular steel, we're coming down to 160 in stainless, right? Because we want this baby to last forever, right? So this is still pretty aggressive, but it's stainless. All right, so let's do it. Plastic to aluminum to steel to stainless steel, the same drill is just making it happen. It's my workhorse. It is the standard. I buy one drill and I can actually run all of these different materials. All right, so check out the holes. Like, oh, they look clean. They look clean. They look beautiful. All right, so let's step it up a little bit. Let's go to titanium. The same drill that went into the plastic, that went into the aluminum, that went into the steel and the stainless. Now we're going into 6AL4V titanium aerospace grade. All right, and now our surface footage, our SFM, is going to drop from 160 for the stainless down to 100, right? The material's harder, right? You see it? 100. And then instead of at 7,000s, we're gonna go to 6,000. So 0.006 for our feed per rev. All right, titanium, you ready to do it? Man, it's like cooking with Titan, right? Because I'm just giving you the ingredients. I'm giving you the tool. I'm giving you the exact documented speeds and feeds for success. And basically, we're giving you the cookbook. Titans of CNC, our YouTube channel. It's the cookbook, right? But it's on a high level. So then you guys just take everything that we give you and you actually put it into action and you compete and you guys make it happen. All right? I'm just having too much fun. All right, let's cut some titanium. same drill. It made it happen. It's my workhorse. It's my standard. Oh, love it, love it, love it. Now that we did the titanium, you know, and we had success, you know, before, I actually have another video on this YouTube channel. We started the master class, right? So we're like teaching every single tool to do different hard materials, right? So we're working on Inconel, and during the master class video for making the Inconel part, I actually used the Go drill. It was a 3/4 though. It was bigger. It was a bigger beast, right? It was a 3/4 inch Go drill, and I used it in Inconel. And I used it to drill Inconel 625. My surface footage, my SFM, was at 84, right? So 100 for titanium. Now we drop down to 84 for Inconel. It's hard. There's a lot of nickel in there, right? Almost probably close to 60% nickel, okay? And some chromium and different things and stuff. But it's a hard material that we use in aerospace, right? It's like, So 84 SFM, chip load, feed per rev is 0.004, so 4 thousandths. Getting after it. Boom. And that's a cool thing, right? Because it's the same drill. It's a 3/4. Like that one was a 3/4, but this is a 1/2 inch, and I'll have a 1/4 inch, and I'll have an 1/8 inch. And the cool thing about these drills, like they start like way down at like 1 millimeter. Like what is 1 millimeter? Like 0.03937. Boom. Like that's a millimeter in inches, right? So like that's tiny. So this drill actually comes that small, and then it goes all the way up past 3/4 of an inch. So that's a huge range, and that's why it's my workhorse. That's why when I quote things and I do things like one-offs or 10 pieces or 20 pieces or 50 pieces, I just use the Go drill. When we get into production, we're actually running thousands of holes. That's when I switch over to the modular to save money, because then we just replace the tip. All right, so this was cooking with end mills. We're giving you the ingredients, making it happen with titans of CNC. Oh, I'm passionate. All right, you guys have a great day. We're gonna do some really cool videos coming up. So just stay tuned, subscribe to this YouTube channel, and hit the likes and give us the comments. I'll keep talking about what you wanna hear about, all right? So it's a conversation, we're family. I love you guys. Boom, I'm out.